Hello, hello. I thought this might be helpful as people are in and out of class, as I'm in and out of class, to do our review via video notes. Uh, please try to answer the questions on your own and then go through the video, see what you missed, use it to fill in the gaps. Following along with me is one thing, it's better than nothing. Looking in your own brain to find where this information is and practicing finding that is even better. So, quick literary review. We got some just overall unit reviews coming up. Uh, Today, you're going to be working on the first half of a study guide. It says pages 1 through 8. Um, there's lots of blank space on those pages for work, so don't freak out. Then we'll finish up the study guide next class. And then on this, it's like a Google form where you don't even have to perform the hypothesis test. It's just more practice with which test should I do here? Let me look at the information. Which test should I do? Um, the scoring exercise, we're going to read through some FRQs that were written and submitted by students in 2022. And with those and the scoring guides, practice scoring them. I think it's a really good exercise in understanding how to write a good FRQ if you've practiced assigning the scores based on the scoring guidelines. These full AP, FRQ, and MCQ, those are going to be with a partner. I haven't decided yet whether that's going in as a test or an assignment. Make your case. We have a visitor coming to talk to us about working as a statistician for realsies. The way timing worked out, sixth period, we'll do that on Thursday the 1st, and then second and third, we'll do that Friday the 2nd. On those days, we've got another circuit review. We've got more inference practice, just practice, practice, practice. Then we gotta get good sleep. And your test is on the 8th at 8 a.m. Make sure you're on time. Make sure your computers are charged. We will definitely have some time in class to go over any last minute questions. At the bottom of the front page here, you can see the whole test schedule. I listed all of the tests that I believe you might be taking, so you can kind of plan accordingly. I don't think any of you, maybe one of you, is in world history this year. But other than that, this should be your only thing to worry about that day. Then you have a nice break before econ in the afternoon on Friday if you're taking that. Yeah, so hopefully in pretty good shape. All right, so the deal with vocabulary. It's really important. There's a lot of specific words, either words that just occur in statistics or words that are very specific in statistics. So make sure that you are using the statistical definition when you're writing these flashcards. I want you to do these by hand, ideally. No, yeah, by hand. There's just something different in the way your brain processes it when you write it out versus when you type it or build a deck from existing cards. And notice 1 point of extra credit in the test category for every 5 flashcards. So I've broken this down by unit as best I can. Some of these things occur in many, many units. So it's just kind of where they are most prominent or where they appear first. And you can see that there is quite a lot of opportunity for extra credit. So very worthwhile. And especially, going through the Google form, what you know how to do, what is a little shaky, this will be a great way to get an overview. A lot of folks were saying they're still not super clear on the chi-squared test. Start there, right? You don't have to do these in order. Yeah. So whenever there's downtime, if you have any extra time in any point, make another flashcard. I probably don't have enough flashcards for everyone to have some, but I do have some. Talk to me if you need anything. All right. So, with that, let's dive in. Now, I left lots of space. That doesn't mean we're going to fill it all up every time. So first things first, unit one variable data. So when it says describe for a one variable quantitative distribution, describe the distribution of test scores, describe the distribution of, marathon times. This is when we cusp ES. So again, we've got center, unusuals, shape, and spread. And then the BS, of course, is for be specific. That is definitely something I continue to notice. You need to include the context. Don't say the center is 15, say it's 15 minutes. Don't say the spread is 20, say that it's 20 minutes. Put those units in, there's your context. And use the specific numbers as well if you have them. Yeah. In terms of, for each of these, the center, I'm going to move these around a little bit. So the center, that could be your mean or your median. You don't need to include both. Looking at the distribution, decide which is a better measure of center. Give it in context. Unusuals, we're talking about gaps, clear gaps, or outliers. And this could really be and or outliers, right? Anything that's not like with the pack. Shape, is it symmetric or skewed? If you are going to say that it's unimodal, so if you're going to say that it's unimodal, do not say that it's uniform. Uniform, remember, means that everything is the same height. Don't get those mixed up. If it's uniform, you can call it uniform. Duh. But if you mean to say that it looks like this, it's got one bump, don't say that it's uniform. Okay. Cool. And then for spread, if you're going to use the mean, then you should probably use the standard deviation. If you are going to use the median, and let's say you don't have the specific numbers, you can't get the standard deviation, whatever, then you should use the IQR if you can get that. And again, that's just Q3 minus Q1. Or the other option would be the range. If that's the best you can do, that's the best you can do. And remember, the range is a single number, max minus min. Be careful not to say the range is from 1 to 15. That is incorrect. The range is a single number. Okay, cool. Think we're pretty solid on that. Lots of good descriptions. Now, let's say we have two one variable distributions we're comparing. If you see this word compare, you must use the word than. Group A's mean is 5, which is lower than Group B's mean of 6. Lower than. If you just list the facts, you do not get the point for comparing. You actually have to say this group is larger than this group, or it's the same as this group, or it's smaller than this group. You have to say the word than. Are there other ways to get the comparison point? Sure. If you use the word than, you're going to be in pretty good shape. All right. That's all we're going to do on that one. That's all we need to do. Cool. Next up, test statistic. So in your formulas, we can think about this in words. We can say statistic minus parameter. And remember, the parameter is just the population value. So that's our mean, it's our expected proportion, whatever it is, statistic minus parameter, all over the standard error of the statistic. Can I spell statistic? Okay, great. Another way you could say that is actual minus expected. And remember, another name for expected value is mean over the standard deviation. Symbolically, you can think about it as x minus x bar over s, or x minus mu over sigma. Lots of different ways to think about it. A really common thing that we use as our test statistic is a z-score. Looks like scare, sorry. Z-score. Sometimes we also talk about this as our t-score. The chi-square test statistic is also a test statistic, but it's calculated a little bit differently. So I want to acknowledge that it is also a test statistic. We're just not going to put it right here. We'll do that when we get to chapter 8. All right. Now, the meaning of a test statistic. It tells you how many standard deviations from the mean your value is. Now, get this question occasionally. Can a z-score be negative? Totally. If it's positive, then your value is above the mean. If your test statistic is negative, the value is below the mean. All right, this quotation just the same as above. All right, onward and upward. Find a z-score given the percentile. Okay. We're looking for, in this case, a z-score. This is when we're going to use inverse norm. We're going to put the area in, and that is really just the percentile as a decimal. So, for instance, if you want to find the 80th percentile, then you put in 0.8 as your area. Then, since we want a z-score, the mean is always going to be 0, and the standard deviation is always going to be 1. Now, if you have one of the newer calculators for inverse norm, you might have an option to include the direction. If we're using percentiles, it's always from the left. Every bit of instruction I have given is always from the left because not every calculator can center this inverse norm or go from the right. So if your calculator can do that and if you understand how to use that, awesome. If not, just leave it defaulted to left and don't change it. Okay. So next up, finding a z-score given a proportion. I'm going to do a little cheat code here because it is exactly the same thing, except it's the proportion as a decimal. Basically the same thing though, right? If we want to know the z-score for where 3/4 is going to be below, well, we just put in 0.75 as our area. If we want to know the spot where 25% is above, we're also going to put in 0.75 as our area, because then it'll give us the 75% left of that. Okay. Good. Next up, finding the value given a percentile, mean, and standard deviation. This is when we use inverse norm with our values. Since we, in this situation, have both the mean and standard deviation, we can plug those straight in. So we want to put our area. So this is the percentile as a decimal. And then you're just going to put in the actual value of the mean and the actual value of the standard deviation. This will pop out the value at that percentile. We want to know what score is at the 95th percentile, at the 90th percentile, whatever it is. If we know everything, we can put it straight into inverse norm. If you don't know the mean or standard deviation, or if you only know one of them, then you have to use inverse norm and z-scores, and then do a little bit more algebra to find the values. Okay. Next, find the percentile or proportion given a value, a mean, and a standard deviation. So honestly, you guys are pretty good with this, but I thought we would break it down just to make sure we're covering all our bases. So first up, if we want to know what percent or proportion or what the probability of being less than a value is, these are all going to be our normal CDF. When it's less than, that's when we use our negative infinity, our value, mean, and standard deviation. Okay. So the key is that since we want it to be less than, we want it to go to negative infinity. And as always, if this is in FRQ, you want to be labeling everything. These are the labels, basically. But when you have real values to use the labels as well. And so remember that this is our lower bound and this is our upper bound. Okay. Thinking about a curve that would go with it, whatever our mean is, let's say we're here and we want to know what's to the left of this. Left less. Okay. Much in the same way, but not totally the same. If we have something and we want to know the value greater than, we're going to again do normal CDF. This time our value is going as the lower bound. The upper bound is positive infinity, or an approximation of it. And then we put in our mean and our standard deviation. And so the picture for this, and this is why I'm always telling y'all to use pictures. Okay, we want to know what percent is above that value. It would be totally possible that you have a value down here and you still want to know what percent is above that value. Then you just get a probability or a percent above above 50%. Typically not, though. I did just notice a typo here. We want to know the percent or a proportion, not the percentile. Percentile you can only get from this one. This one will give you the percentile because the percentile is that value and lower. Okay. So last step, between two values. running low on space here. So we're going to have normal CDF. And we're going to have our lower value, our upper value, our mean, and our standard deviation once I can fit it. Mean and standard deviation. And again, this is what we would get with two tails, right? So between two values, if this is our mean, that would be here. We could also, if we wanted to know the area here, we would just calculate this and then subtract it from 1 because all the probabilities add up to 1. So there you go. Okay, so finding the percent or proportion given a value, a mean, and a standard deviation. Next, find a percentile given, or excuse me, a percentile or proportion given a z-score. It's basically the same as above, but for the mean and standard deviation, since the mean and standard deviation of z-scores are 0 and 1 respectively, you just use those as your mean and standard deviation. So it's normal CDF. You're going to have your lower and your upper bound. And, you know, basically the situation will dictate whether you're here, here, or here. And then for your mean, it's just going to be 0. And for your standard deviation, it's just going to be 1. Okay. So find mean and standard deviation given two values and their respective percentiles. Okay. What you can do is you first have to turn the percentiles into z-scores. Percentiles into z-scores. And we'll do a sample in a second. Then we're going to find the difference in values divided by the difference in z-scores. And that should give you your standard deviation. You're going to then plug a value, z-score, and standard deviation into z-score formula to solve for the mean. Okay, so I'm going to shrink this down. Let's go through that together. I purposely sort of did like abstract and then we've got some sample problems. So I'm just going to completely make up these numbers. So let's say 27 is at the 27 is at the 60th percentile. And 36 is at the 72nd percentile. So to find the z-score, we're going to have to use inverse norm. Probably should have grabbed my calculator before starting to record, but that's okay. We'll survive. Got a lot of FRQs to move before my calculator makes its presence known. It is possible that my very trusty and beloved calculator is sitting at school. That would be most unfortunate. Okay. Is that the case? I may have put it in my coat pocket because I was taking a lot of things out of school. Is this really exciting for you to watch me think about where I put my stuff? Well, let's just look it up. I'm going to use a slightly different calculator called NumWorks. It's pretty good online. I don't recommend it yet. I might, just because the TI has good applications in other situations, but it's pretty good for stats. Okay, so we are looking at distributions, and we're looking at normal distributions. And okay, we were mean and standard deviation. We're trying to find a z-score right now. And live. Okay. Would it be in here? No, not in there. Pretty sure it's in distribution. Should be normal. Because we don't know the mean and standard deviation. No, we're going to try something else. Calculate. Oh, wait. No, I'm being silly. So it's a z-score, so it needs to be to the left. And the probability is our area. Okay, there we go. So I know the area for my first value is 0.6 because it's at the 60th percentile. I'm going to say my area is 0.6. And so then it's giving me a z-score of 0.253. So I know that the z-score here is 0.253. And then the other one I said was at the 72nd percentile. So I'm going to put my area in as 0.72 and calculate it. And then my z-score for that is 0.583. And I'm just rounding to 3 decimal places. 3. Okay. Cool. Thanks for bearing with me. So we're going to take a difference in the values. So 36 minus 27 over the difference in the z-scores in the same order. This should be, I mean, be careful about how you're subtracting it. Basically, you should be getting positive numbers here. So 0.583 minus 0.253. So on top, we're going to get 9 divided by, okay, now just regular calculation. Can we do it? Aha. 9 divided by 0.583 minus 0.253 is 0.33. And then if we do 9 divided by that, 9 divided by that, we get a standard deviation of 27.27. Yeah, that makes sense. I went up 12 percentiles and 9. Yeah. All right, so 27.27 is our standard deviation. And then to find our mean, we're just going to use that standard deviation. This is our, and we're going to say, I'm going to use the 27, 0.253, that's our z-score, is equal to 27 minus the mean over 27.27. 27. So now we algebra, we're going to multiply both sides by this. So will this work? Yep, times 0.253. So we get 6.9 is equal to 27 minus the mean. And then we're going to subtract 6.9 minus 27. And we get negative 20.1. We're going to get negative 20.1 is equal to negative x bar, which means the mean is equal to positive 20.1. Okay. So, like I said, hopefully we'll get some time to work on more of those, but it comes up some. Once you get the hang of it, it's nice points for you, but it's okay if you're going to need a couple more rounds of practice. All right. So I'm going to pause the recording there, and then I'll do a separate video for just walking through the problems. Then I'll do the same for units 2 and 9. So I will see you soon.